Well, thanks for appreciate you guys staying. I know always the last session is kind of difficult to stay on. But let me a little brief about the company. So we've been since 2009. We really launched in about 2013. We're in Palo Alto, about 50 employees and hiring really. We need more people. And we are funded, and we have about 100 plus clients at the moment. The focus of and what drives us is really the notion of how we deliver integrity back into the digital commerce market with our notion of trusted digital identities. And we'll talk about that in a minute, but it's really the concept of digital identities is really how we can evaluate transactions based on the notion and the attributes of those transactions that link back to the identity. It's a SaaS platform. We really focus on online fraud prevention and automation of compliance. So primarily associated to anti-money laundering. So anything that has to do with the Bank Secrecy Act and things to do with KYC, sanction screening, transaction monitoring, and so forth. Our clients, we do good things, but we really focus in trying to optimize the operations. So we focus in the compliance automation. We focus on the reduction of the manual review processes for both fraud prevention and for sanction screening, for example. So for you, those of you that are associated with fraud and the fraud operations, you know that this can be a very problematic and a very time-consuming matter. So we really try to focus on that. Our basic concept is trusted digital identities, and ideally what we're trying to say is that you can define and you can identify better the risk of a transaction if you know who is the person behind that transaction, what level of certainty do you have behind the user of that transaction. So we basically want to answer 4 questions. We want to answer, is this a real person? So you're not dealing with a synthetic identity. You want to know whether the information that is being presented, it belongs to the actual person. So you're trying to prevent things like identity theft or account takeover. You want to know that you can do business with that person. So that means that your government has not sanctioned this person as a terrorist or as a money launderer or somebody that you cannot legally do business with. And you also want to make sure that that person is not going to damage your brand. So you want to know that that person may not be associated to the financing of terrorism, human trafficking, drug cartels, and so forth. It looks kind of this. There are many companies that do identities, and they try to say what the digital identities are. For us, digital identities is really a mix of many things. So first off are the usual parameters that you define an identity for, like name, address, social security number, date of birth, and so forth. Once you go into online world, and you're talking about email and IP geolocation and devices and so forth. That, for us, it conveys what we call a simple identity. It's an expression of that identity. But as you know, as many of us, we have multiple identities online. And we're not just a single identity. We're a collection of multiple identities. And that's where the rest of the stuff starts coming in. So you have to be able, especially in fintech applications, where most of your applications are catered to the inclusion of everyone, right, in the financial system. So you end up trying to validate and verify, people that they don't exist necessarily on the usual databases of like credit bureaus and so forth. So you really have to have ways to know how to validate these users, these consumers. So you need to incorporate social media analysis. You need to incorporate, mobile data. You need to incorporate also document verification. And then on top of that, then you need to look at what is the behavior of those users within the financial spectrum. So have they been validated before? Have they have other accounts? Have they have other online accounts? And so forth. So all of this is really what fuels our technology. So in the core is basically a gigantic entity link analysis. And part of what we're going to present today is the advances of the analysis of that graphs of entity links with machine learning processes. So underneath the trusted digital identities, we have our concept of electronic DNA, which is basically how we represent an identity within our platform. And to talk a little bit more about the technical aspects of that, Kieran, who is also founder of the company, can talk a little bit about it.
Hi. So of course, this is a cloud-based, it's a SaaS platform with a REST-based API, JSON encoded data. We're not going to say anything more about that. What's happening within the system is we are building reputation for each of those entities that Jose has mentioned. So for the payments, for the users, for the device, IPs, various addresses. And we're building this reputation not just from the transaction flow itself, but from what we call feedback, which is information from our clients about the final disposition of a transaction. So this can be hard data, like bank auth data or chargebacks, but what's often much more useful from a reputation build perspective is the soft data of this was a manual review, I looked at this, I've accepted this transaction, or I've rejected this transaction, or at the end of the transaction flow or lifetime, that this transaction was refunded. There was a proactive refund to avoid a chargeback. Having reputation for each of the entities in the transaction is necessary, but not sufficient. Device reputation is great, payment reputation is great. But what we need to do is put those reputations together in the context of this particular transaction, along with the knowledge that we have about the relationship between these entities and how they've related before and how they're relating at the moment. And this reputation is shared across our client base. There's no sharing of transactional information itself, but we extract the metadata, and that's shared across our entire client base.
So the way that this looks in our system, and this is what the eDNA looks like, but the details of this is that each one of these key entities that we call in the system, those roll up several attributes underneath that. And the color coding tells us a little bit about the reputation of these particular entities in our system. So the green is good, the red is bad, kind of thing. There are shades of that in between. So the purpose is that when you are doing entity link analysis, what you're trying to figure out is that the data that you're seeing is not isolated. So when you look at an identity theft, for example, the attributes themselves may not be compromised, may not have a bad reputation, but you have to understand what is the likelihood of those attributes being connected to other attributes that may be complex. And this is where the whole graph starts becoming very interesting. So what we looked at in our experience over the years doing this is that there is a very direct correlation between the complexity of the graph and the risk of a transaction. So the more complex the graph is, the higher number of entities, the worse reputation across those, and the rate of growth of the graph is very indicative of the risk of a transaction. So graphs tend to get much more complicated. So for example, a graph can look like this, right? And this is how easy that is visually. You can go and say, okay, there's a real likelihood that this is a money laundering ring or a fraud ring. And we've seen many of those across in our clients. Now, in order to be able to analyze all of this in real time, it's a bit more complicated. So, this is one of the things that we are presenting today here is how to get this type of analysis now in real time.
So when we receive a transaction, the first thing that we do is cast a relatively wide net across our database of hundreds of millions of identities. Typically, these are key-based lookups where we pull in a set of candidate entities for this particular transaction. We then run more intensive algorithms across this smaller set to pull out exactly which identity is the best match for the current transaction. So, of course, we're doing this in real time. We're doing this eDNA matching as part of the pipeline. Also, we're running an anti-fraud policy. We're accessing third parties. We've integrated 20 different third parties that you can choose to access, depending on the reputational flow of the transaction. We're doing anti-money laundering, sanction screening, et cetera, et cetera. Back in 2009, when we first began building this platform, NoSQL wasn't really a thing. Graph databases weren't something that we were prepared to build our entire platform on. So we ended up on MySQL. But of course, over time, we've gotten to the limits of where we can go with this technology. Two areas in particular, the complexity of retrieving graph-based data. You saw this is very graphical data. Graph-based data from a relational database. And secondly, just the complexity of managing multiple data centers, master-master replication, sharding from the application. So about 18 months ago, we made the commitment to rebuild a platform, in particular to support the graph intelligence work.
Yeah, and as I was saying before, the idea was, okay, we know, because we've been doing analysis in the back end, that there is this relationship between, this direct correlation between the complexity of the graph and the risk of the transaction. So what we needed to do then is calculate that score and that likelihood of risk and how we represent that in real time through the APIs. So that's the work that we're doing, and that's the work we were able to do based on the migration of the backend to a graph database. And basically that incorporates all the elements that we have seen very direct correlation to the risk of a transaction. So we're taking into account the rate of the graph, the depth of the graph itself. We can go all the way to 10 degrees of separation on the graph. And it's very challenging because you have to make sure that you're not connecting the world, right? So there are certain things that you could follow connections forever. But one of the challenges is how you actually make sure that graph is associated with the elements that you are talking about and not some mistake, which we see in the data as well. And then one of the things that is important is that the metadata and the analysis that we're doing is not on the transactional data, but is in the data that we call the eDNA, the electronic DNA that I was referring before, which is what we call the metadata, and that metadata captures the behavior across all our client base. And our client base is money remitters, is peer-to-peer payments, is online lending, is e-commerce, and many other things.
So the platform that we ended up on was, which we have just rolled out, is Cassandra-based and using Titan as a graph database. As an example of an efficiency that this has given us is that a single line of Gremlin script, Gremlin is the query language for graph databases. It's able to replace several thousand lines of complex recursive Java code that was putting together the data from multiple SQL queries. Migrating is hard. We did this live with no downtime. 50% of the project duration was managing and getting this migration to take place. I won't say anything more here, but I'll be at the booth later. If anyone's interested, if anyone is going through this at the moment, I can answer questions. I can give you more information about our experience. While building the second generation platform, we integrated machine learning. Particularly initially in the area of the graph intelligence. You saw a graph that looks really messy. Clean graphs are really obvious as well. We want to automate that process of being able to know that a graph is a good user. We have much training data. We have good labels from the feedback, so this has been a relatively straightforward process.
Yeah, and we started analyzing these graphs, and what we're presenting today is really early results with some of our key clients. But you can see in this map that is very clear to know where those big spikes are and trying to separate the good from the bad. A lot of what we're trying to do, and this is something that our technology is more fundamentally is better at, is trying to understand who are the good users versus who are the bad users. And any of you that is on the business side will appreciate the fact that we're trying to make sure that you accept the good users, because one of the issues with risk is that you end up either making your clients to go through more friction because they are more risky, right? So the better you know those are good customers, the higher the percentage, the easier the process is going to go. So we've done this with several types of clients, and the reputation that we found, the thing that we found that is key is the reputational value. So we have 3 graphs here from 3 different types of clients: money remitter, a digital wallet, and e-commerce site. From top to bottom, we get better reputation on the bottom side. And as you can see, the fraud, which is the great aspect of that, is much more concentrated when there's more reputation in the system. So the more feedback you provide back to the system, the more we know about these clients, the more predictive they are about the good users of the system. So in summary, focus on identities and their great reputation. Reputation is key because they can translate across. Is a real-time analysis on complex graphs, requires really proper data architecture, and I think that's where we spend the most time of it. And the success of this intelligence really, in our experience so far, it really depends on how careful you are on that metadata layer on top of the transaction. And we're hiring. All right. Thank you very much.